Hi friends, welcome to GMK tutorials. In this video, we are going to see about the small signal model of a FET. So that FET is nothing but obviously we can call as a MOSFET, right? MOSFET. Okay. So let us see here. So for a MOSFET, okay, for a MOSFET, the IDS is equal to drain current IDS is equal to is a function of VGS into VDS. VGS comma VDS. The drain current, that means drain to source current is equal to, it is a function of VGS into VDS. VGS into VDS. In a saturation region, IDS depends on VDS. Okay, in a saturation region, IDS depends on VDS because of channel length modulation, because of a channel length modulation. So by using a Taylor series, it can be represented as delta IDS. Delta IDS is equal to dou IDS by dou VGS into delta VGS plus delta IDS by delta VDS into dou VDS, right? Therefore, it can be represented as delta IDS is equal to IDS by delta VGS is equal to, it is the inverse of resistance. Therefore, 1 by resistance is equal to GM. Therefore, so it is nothing but GM into delta VGS plus, so here also delta IDS by delta VDS. So that is the inverse of resistance. Therefore, that is equal to 1 by RDS. 1 by RDS into delta VDS. So it can be represented as in the small signal model. In case of a small signal model, it can be represented as a IDS is equal to GM into VGS plus 1 by RDS into VDS. So this is a small signal model. It is a small signal model of a FET. Small signal model of a field effect stars. So this is nothing but a small signal model of a FET. Small signal model of a FET. So at the same time, the gate is at a open circuit with respect to the source. So drain to source and drain, because zero current flows from gate to source. So with the help of the previous equation, how can you represent this one? IDS is equal to drain current. So the total IDS value is equal to GM into VGS plus RDS into VD, right? So therefore, this is equal to in this way. So delta GM into VDS by, so this resistance is equal to 1 by R naught. So this is nothing but generally a drain terminal. So this current is equal to IDS. So this is nothing but drain terminal. Obviously, it is nothing but a source terminal. Okay. Drain terminal, source terminal. So therefore, this is so this value is equal to actually RDS. So this voltage drop is equal to delta VDS. This voltage drop is equal to delta VDS. This voltage drop is equal to delta VDS. So in the input side, this can be represented as a positive, negative. This voltage drop is equal to delta VGS. Delta VGS. Why? Because this is a open terminal. So as per this circuit, the IDS is equal to GM into VDS, 1 by RDS into DS. Therefore, that is equal to this one into this one. Therefore, this is a small signal model. So this terminal is generally called as a gate terminal, source, and this terminal is also equal to drain terminal. Drain terminal. So this is a small signal model of a MOSFET. Small signal model of a MOSFET. Okay. I hope it is clear, guys. Why? Because it is open circuit means that in case of a gate to source, no current is flowing. So the reason for this one, gate is at open circuit with respect to source and drain. Gate is open circuit with respect to source and drain. Because zero current is passing, zero current flows from gate to source and gate to drain, because zero current flows through G2S and G2D, or maybe drain to gate to drain. So that's why it acts as a open circuit. Okay. So this is a small brief introduction about a small signal model of a MOSFET. I hope it is very clear, guys. So thank you for watching GMK tutorials.